right? Good, so let's get started. This is StahlstadtJS, but I'm not going to talk about JavaScript. Today I thought it would be fun to talk about Go, one of my new favorite hobbies, and Go with WebAssembly. Let me begin by telling you a little bit about my personal story towards Go. I don't know about you, but I don't like node modules. Node modules folder. When I do C# development, I do a lot of C# development, and I do a self-contained deployment with C#. It's similar to node modules. I get a folder with hundreds and hundreds of DLLs. This is what I really hate about all these programming languages. I'm also doing a lot of Docker stuff, and I heard quite a while ago that Docker is written in this funny language, Go, with this funny logo here, and I got curious. So I decided, end of last year, end of the year, you have some good things that you want to do in the next year. I decided to take a look at Go. And my first impression of Go was, of course, I did a Hello World program, and I called Go build, and the result was a single file, a single executable. No hundreds of DLLs, just a single executable. And when I put that in a small Docker container, the Docker container had, 18 megabytes. This is new for me as a C# developer. I typically deal with containers with hundreds of megabytes and huge things and a lot of files and so on. I didn't like that. And that was my first impression of Go, and I really liked that. Then I took a closer look on Go, and my first impressions were very nice because, well, Go, as you see here, is a C family-like language, so I recognize the curly braces. Yeah, I know that. I recognized if statements, and I saw for loops that I was familiar with, so I thought, oh, couldn't be so complex. Suddenly I recognized some interesting constructs which reminded me of my very early programming days. I learned programming with Pascal, and suddenly I saw a little bit of C language, a little bit of Pascal language. I liked the language, but then I started to program with Go, and I thought, okay, it looks good, so let's create a class. Oh, there is no class. There are no classes in Go. Then I thought, okay, let's deal with structs, do some inheritance. Oh, there is no inheritance in Go. Then I thought, okay, write a little bit of code, do some error handling. Oh, there is no try-catch in Go. Of course, put some values in a list. Oh, there are no generics in Go. Then I read that there is a linter in Go, and I thought, okay, where is the linter config? I'm used in JavaScript having these large JSON files where I can tune which warning I want to turn on and turn off, and I wanted to turn off the strange things with the mandatory comments on uppercase functions. I didn't like that, and I read, okay, there is no way to configure the linter in Go. You just run it, and it has to work like that. You have to just deal with it. And that's it. So this was my first impression. It was very simple on the one hand, but also for me, as somebody who works a lot with TypeScript and C#, strange because it felt simple and it felt clear, but also somehow restricted and limited. And that was my story into Go. And I decided, okay, I want to learn more. And now I have been programming in Go as a kind of side project for a few months now. I've used it in various small pet projects, and I really fell in love with Go because although it has some limitations, for instance, not having generics still is a problem for me. But on the other hand, it makes it very clear. Less clutter, less complexity. It makes it easy to learn and easy to write. Also, what I really love about Go is the capability of programming with Go routines. Go routines are a possibility to run very lightweight processes on a couple of threads, and Go has very nice programming constructs about running multi-process applications and communicating between the different Go routines. You have so-called channels. If you want to take a look at all the different concepts that I tell you about, this talk will not be about details about Go. We will talk at Go with WebAssembly. But if you get interested after this talk, just go on this GitHub repository. Ask me if you can't take a picture now, and I give you the link, and there you find some links to more about it. So to make a long story short, I liked Go, and Well, of course, I do also a lot of web development, and so I got curious whether Go is also usable in the browser. And I recognized and I discovered that Go works really nicely in the browser, and this is what we are going to talk about today. I set up a sample, and I want to show you this sample and show you how it feels, what the advantages are, and also what the disadvantages are. Okay, so that's it. My example that I would like to talk about in the next 25 minutes is a classical programming problem. It's the n-queens problem. The n-queens problem means the 8 queens problem is probably something that you had to program somewhere in your computer science classes, putting 8 queens on a chessboard so that no queen can eliminate another queen. And you can generalize that problem, and then it becomes an n-queens problem, putting n queens on an n-sized chessboard. And I thought this would be a nice thing, so yeah, I wrote a simple application, a simple implementation in Go. Let me start by showing you this simple implementation in Go. And we can also take a look at a few of the language syntaxes. Who has never really digged into Go and have never really taken a look at the source, at the structure? Okay, most of you haven't taken a look at Go. So this is what Go looks like. Yes, yeah, there is a packaging system. Yes, you can import some packages. I will not go into the details. I just want to give you a feeling how Go looks like. First thing, take a look. No semicolons. You don't write semicolons at the end of lines. If you write a semicolon, you get a linter warning. Next one, if you take a look at that one, oh my god, that's error handling in Go. There is a convention. A function returns multiple return values, and by convention, the last one is the error. You can if it after calling the function, so if you want, you can handle it using an if statement, but you can also, as you see here, just ignore it. In my case, I just ignore it. Nothing will happen, nothing bad will happen. Next one, take a look at this if statement. No parentheses. There can't be parentheses. If you do parentheses, Go will remove them. Next one. Take a look at that one. My early days of Pascal. Declare and initialize. A single variable or multiple variables. I like that one. It made me think of my early days when I was a teenager, did my first lines of Pascal stuff. If I scroll down a little bit, let me see. Something like this. Do you want to export a function? You have to start it with an uppercase letter. Do you want to have it private? Start it with a lowercase letter. Things like that are typical for Go. Okay, I wrote a little bit of code here. It's nothing special. Let me see if we have anything else. Yeah, here you see data types. If you have a complex data type, everything is a struct, and you can put interfaces on top of structs if you want, and you can't derive one struct from the other. You can just encapsulate them, and you can compose them, something like this. Okay, good. So we don't want to go into the details. If you want to go into the details, feel free. This is just a simple application, and I also wrote a bunch of unit tests. So here you see a bunch of unit tests, and no, there are no assertion. You just have to call an error function, which essentially will return an error, and this is what unit test looks like. So let me go into this folder. Let me start with that one, and here it is. And you just say go test, and this runs our unit tests. We don't need to build them. Everything is fine. All the unit tests pass. This is our starting point. We don't want to take a look, as I said, on the details of the code, but now you've got an impression how this stuff really works. By the way, what is the sweet spot of Go? Which kind of applications work really nicely with Go? CLIs and web APIs. These are the two most used categories for Go. So if you want to implement a simple CLI, which is cross-platform, works on all operating systems, and all you have to deploy is a single executable, then Go might be interesting for you. Same is true for a web API. Things like protobuf, JSON integration, web server, flags, command line interface flags, and things like that are all built into the language. So this is really the sweet spot where Go can be used. So I implemented this example, and to show you what this example does, I've implemented a small CLI. That's a typical command line interface written in Go, and as you can see it here you see command line parsing. It's built into the language. You just say, which command lines do I have, which type do they have, and you're done. Print usage is built into the language. Really nice. What else do we have? Yeah, by the way, Go has a garbage collector, so you don't need to free memory. Garbage collector is already there. It has a strong type system, and it has a bunch of really interesting stuff. For instance, like this. This is a for loop. For is the only loop that you can have. So in this case, I'm iterating over a collection, for instance, and you get an indexer and a variable covering the element that you loop over. Okay, let's build this thing. Let's go into the Queen's problem CLI. Here we are. Currently, let's erase the executable. I'm currently on Windows. Okay, Go build. It takes the Go file. The Go file imports the library that I've used before, and what I will get is a single executable. See that one? And if I run it, let's make this thing a little bit larger. Okay, let's run it. Okay, it found for 8 queens, it found 92 solutions, and they seem to be right in 4 milliseconds. Let's remember 4 milliseconds with the CLI. And if we say -p, I implemented a little bit of printing, so you see the different solutions. If you want to take a look at it, that's it. Okay, now we were even faster. In 2 milliseconds, we were done. This is the CLI. It has nothing to do with WASM, but also it caught my attention because you can build a Linux executable on Windows. You can build a Windows executable on Linux. You can build a Mac executable on every. It really is very, very simple. I like that one, just having a single executable. That works essentially everywhere. Well, when I had the CLI, I decided, okay, what I typically do, not only writing CLIs, but I want to encapsulate the business logic in a web server. So the next thing that I wrote for this talk is a small little web server. Let's take a look at that. This is how you implement a web server. You have a kind of router, as you can see it here. You implement a bunch of handling methods, and the bunch of handling methods are, for instance, here. This is a typical API. You have a method, you do a little bit of JSON encoding and decoding. JSON support is built into the language, so you can, just to give you an idea of that one, you can immediately, when defining the struct, define the JSON names and things like optional, non-optional. This is all built into the language, works really nicely. And at the end of the day, you're encoding a bunch of results and sending it back to the client. So, nothing special. We are still using, as you can see it here, the same class library that you have, not class library, the same Go library that you have seen before, but now encapsulated on the server side using a web API. Let's run this web API. Of course, if you want to run this web API, I need to somehow encapsulate it, and hey, we need to do Docker here, okay? So what I've built here for the web API, I've built a Docker file which takes the Golang base image, uses it to compile the language. You see, Go build with a bunch of flags, very simple. And then you take a plain Alpine base image, copy a single executable into the Alpine image, and that's it. No complex base images at runtime, just take the executable, put it in an Alpine Linux, and that's it. And you can go one step further. If you statically link everything, you can create the Docker image from scratch. You don't even need Alpine if you don't want it. You're sitting directly on top of the Linux kernel and it just runs. This is what makes me like this stuff. So I already built this thing here. You see it. This is the Docker container. Let's run this guy. Let's do a port mapping. Let's give it a name. And let's use this guy. Good. Let's run it. Good. It runs. And here I have a small demo file. And it should call our web API. Here it is. For the 8 queens problem, we get, as you can see it here, on the server side, 92 solutions in a little bit above 2 milliseconds. That's fine. The nice thing is, if you take a look at the web server here, this is the web server, that we have approximately 18 megabytes. That's nice. That's the whole Alpine Linux with the web API, with the class library. Works good. My next thought was, okay, now I have the stuff on the server, but I would like to reuse the code that I've written on the client side. And here is where WebAssembly comes into play. I would like to reuse the same application logic, the solving logic for the 8 queens problem, inside the browser. That's the important one. So I decided to make it very simple and just take a command line version which calls my solution, this one, and just prints the result on standard out. And it turns out that you can compile a Go application just by specifying as JavaScript as an operating system and architecture WASM into a WebAssembly file. That's all you need. It's just a new compiler target. And again, what you will get is just a single statically compiled WASM file. And you also get a little bit of JavaScript helper, which makes it possible to directly call this WebAssembly in Node.js and also in the browser. Let's give it a try. I already ran this Docker file to make things a little bit faster. So let's kill this guy, docker rm f746, goodbye. And let's run the next one. And the next one is the qp simple wasm. Good. Let's do it like that. And let's get up the network here and go to localhost 8080. Good. Let's take a look in the console, and you see here you have exactly the same code. This is my library now running in WebAssembly, printing exactly the same stuff on standard out. Okay, so I'm using a command line interface tool and printing it on the console. Okay. Of course, I also see the result here. But I guess you are interested in how long we took, and you already see it here. Oh my God. That's Go running natively on top of WebAssembly, and it took 28 milliseconds to solve the 8 queens problem. That's not a generical statement about the performance of Go on WebAssembly. You have to measure on your own. That's a very, let's say, artificial statement which does a lot of ifs and fors and so on. But in general, what I can tell you, don't expect, just because it's WebAssembly and is natively compiled to WebAssembly, to be faster or at least equally fast to a native speed. No, we are here with a factor of 10, more than 10. We need 28 milliseconds to calculate this solution. And if we take a look at the network here, the WASM file has a size of 681 kilobyte and, 2.6 megabyte. And here I'm using an Nginx web server with turned on gzip encoding. So I'm getting down to 681 kilobyte for this example running this solution. To be honest, when I prepared this talk, this didn't make me smile. I was a little bit, let's say, confused what this means for using Go in WebAssembly. To be honest, if you just use Go like that, the big advantage that you get is code reuse. But don't expect performance gains, okay? Not the case. By the way, I also ran the same example, if you want to take a look at it, because I was so curious. I've translated the same algorithm into JavaScript. And I've also translated the same algorithm into C++, where I use emscripten to convert the C++ solution into WebAssembly to find out how large it is and how fast it is. Do you think JavaScript is faster than Go with WebAssembly? Yes, it is. So I thought, okay, use it for a 12 queens problem, because then we calculate more and I should see a positive effect. Do you think that WebAssembly is faster than JavaScript in this example? No, JavaScript was faster. The C++ version was equally fast. But the WebAssembly solution, at least in this example, wasn't as fast. However, I still, and I don't want to tell you that Go in the browser doesn't make sense, I still have the big advantage of being able to use the same code on the client if I need it. I wasn't okay with that, so I took a closer look, and it turns out that there is an alternative Go version, which is called TinyGo. TinyGo is a lightly simplified version of Go, so you don't have all the language possibilities that Go has. And the target for TinyGo is IoT scenarios and things like that. And not a big surprise, you can use TinyGo to compile Go into WebAssembly. So I took a look at that one. So let's take a look at this one. This is the Docker file for TinyGo. As you can see, I installed TinyGo here, and the only thing is I'm here using the TinyGo compiler to compile everything into the WASM target. Okay? This was my second try with the Go stuff, and well, let's give it a try. So let's do that one, and TinyWASM. Good. Let's see. Console. Looks good. Ah, I like that one. See that one? So TinyGo looks much better. Now we are, let's say, on par with JavaScript and similar solutions. Now we can solve the 8 queen problem in approximately the performance that we had on the native part. And if we take a look at the size, if we take a look at WASM here, oops, sorry, this one, then you see the size also looks much better. Without compression, it's 61K. With compression, it's 30K. That's okay. So this is a takeaway that I can give you. If you like Go, like me, and you would like to run your code, your business logic, on the browser, then it is maybe a good idea to take a look at TinyGo and try to compile your Go code into WebAssembly using TinyGo instead of Go. But be warned, TinyGo doesn't support all the features that Go do, and also the whole memory model is much more limited, so don't take it for granted that all your complex Go algorithms just run on TinyGo. You have to test it, and TinyGo is also very experimental, and it's on a very early stage. Okay? So, you want to see how the C++ version did? Let's try that one too, just to be complete. Oops, already one running. Good. This one. This is the C++ version. Here we are. Okay. You can try it with 12. The size is also important. See that one? emscripten 150K, 53K compiled. So compare that with the TinyGo that I showed you. So TinyGo does a pretty good job compared to a native C++ implementation, which I compile with emscripten down to WASM. See? But you see the JavaScript here? The JavaScript is pretty large. It is also generated by emscripten, so you have 100K here. I don't compress the JavaScript in this Nginx configuration. I just compress the WebAssembly to, because I wanted to take a look at the WebAssembly stuff. So you can try the JavaScript on your own. I don't want to show it because it's embarrassing, because it's the smallest one and it's the fastest one. So, Good. So, in this example, what was the takeaway for me for this talk when I was preparing that? I still like Go. I still like Go for command line interfaces. I still love Go for writing microservices and things like that on the server. And what I learned is that I can use the programming model of Go very easily and simple on the client if I need to reuse code. So if I don't want to write it twice and I just need the logic on the client, that's fine. But I have to be very careful when doing that, because it might not be the most performant solution and it might not be the smallest solution. If you want to go for the smallest and most performant solution, you should take a look at TinyGo because it supports very nice things. Of course, people have done really crazy stuff with this Go and WASM support. Did you know there is a Vue Go implementation, which is a kind of Vue where they replaced JavaScript with Go, so you have this Vue templates, but to write the business logic in Go, highly experimental. I tried it a little bit, but in 30 minutes I can't show you that. But if you are interested in, take a look at it. Don't expect it to be very fast or very small, but it shows a direction where it goes to. For me personally, WebAssembly is still a fascinating thing because it opens the browser to very different programming languages. I know we are not there yet, but there is a lot of potential in it. And I think in a few months or years we will see WebAssembly and WebAssembly-based algorithms being more and more performant and being more and more efficient. But this is the current state. This is where we are currently with Go. And yeah, I will keep on experimenting and trying Go for implementing my client-side logics. This is what I wanted to show you. I have a lot of code here that I can show you, but I want to open it up in the last 4 minutes to you. Maybe you have some questions which we can discuss. Any questions? Yes?
Could you use all the language features with TinyGo that you used in Go? Or did you have to rewrite it?
In my example, it's exactly the same code and everything just worked.
Okay.
One important thing, Go, I told you about the Go routines. We know all JavaScript is a single-threaded programming model. Go routines are part of the programming language. So you still can use Go routines and channels and so on, although you compile Go into WebAssembly. So this is on the topic of the programming language features. There was another question.
Did you consider to try Rust?
No, because I've never tried Rust. Okay. Yeah, I would be very interested in seeing it in Rust and how it compares. If you would like, take my algorithm, translate it to Rust, send me a pull request, and then we can make a challenge. Which one is the fastest one? I would be very interested in that. No, I'm more familiar with C++, a little bit familiar with C++. I had a little bit of help of Arno Hütter. He helped me because he's a really good C++ guy. And therefore, I wanted to try it with C++. No, I didn't try it with Rust. Any other questions?
Do you have any idea why, I mean, it's called TinyGo and the WASM file was quite small, but do you know why the execution time was so much more, so much faster?
No. You mean so much faster than the other one? No, unfortunately, I can't tell you the reason about that. I really can't tell you. No. No, I don't know the reason.
Because stripping away functionality explains the smaller WASM file, but
What
not the speed.
What I can tell you is I have tried a 12-queen problem. Of course, I've run the 12-queen problem in all the different variations. And with my algorithm, I wasn't even able to run it. I got an out-of-memory exception when I tried TinyGo because of its memory limitations. I am still curious why this is the case. But for me, the takeaway was if you have an algorithm which needs more memory and things like that, which doesn't fit into a very resource-constrained environment, then you have to rethink your algorithm and maybe find a more, let's say, memory efficient version of your algorithm in order to run it with TinyGo. So you have really serious limitations there. Yeah. Final question, if there is one? No? Yep.
Can I use your computer for the reference?
Yes, of course, absolutely. Just let me show you one thing. This is my GitHub repository. Here you find the whole source code, including the different Go variations, the Docker files, the C++ version, the JavaScript version. Take a look at it, play with it, send me pull requests if you do some experiments there. And with that, I've used 29 minutes, and I think I have to say thank you for having me, and I hope it was interesting. Thank you.
Thank you.